A thermometer shows temperature by expansion and contraction. When the temperature rises, the mercury in the bulb of the thermometer expands and the mercury thread rises. When the temperature falls, the mercury in the bulb contracts and the mercury thread falls. Therefore, the height of the mercury thread shows the temperature reading. The phenomenon of expansion and contraction can be explained by the particle model. Particles in matter move unceasingly. In a solid, particles can only vibrate. Liquid particles have higher energy content and can move around over a longer distance. Gas particles have even higher energy content and can move around over a much longer distance. If an object is heated, or when the temperature rises, the particles in it gain energy. The increase in energy content enables the particles to move over longer distances and the object expands. As particles in a solid have fixed positions, the expansion of a heated solid is not obvious. Liquid particles can move around freely over a short distance. When they are heated, the particles in liquid gain energy and move farther apart. Hence, a liquid expands more than a solid. Gas particles are far apart from one another. As the particles gain more kinetic energy upon heating, they move over a much greater distance. Hence, a gas shows the most remarkable expansion on heating. The surfaces of roads or bridges are divided into blocks and the gaps filled with an elastic material. This design is useful in preventing the road surface from rising or bending when the material expands or contracts. The longest bridges in Hong Kong are the Tsing Ma Bridge, the Ting Kau Bridge, and the Gup Soi Mun Bridge. The length of these bridges may increase or decrease as a result of expansion and contraction. These changes must be taken into account in the design of the bridges. The Tsing Ma Bridge, for example, makes use of movement joints to allow for the expansion and contraction of the bridge. The deck is fixed at the Ma Wan abutment by steel pins to allow only vertical rotation of the deck. From there, expansion and contraction are catered for by sliding bearings at the side-span pier tops and at the main tower legs and by road and rail movement joints on Chingy Island. The road movement joints consist of a number of steel beams laid transversely across the deck, closely packed together and joined by a rubber coating. As the bridge moves, the joints slide along further longitudinal steel beams supporting them from below, the beam and rubber combination above stretching or contracting like an accordion. The movement joints on the rail are designed to accommodate the full range of deck movements to a limit of 1.1 meters in each direction. They might be the largest of their kind in the world.